Dr. Richard Carrier, Noah Chris, I hope I'm saying his name right, he has a few questions, a few more. We've had already a couple. He says, question, a case could be made that what we call the Industrial Revolution did not actually start with the advent of steam power, but instead started in England when water wheels were connected through elaborate gear shaft and belt systems to automated looms. How close did the Roman Empire come to this critical industrial innovation?
Yeah, belted looms is pretty late. So the water wheel with gear trains, that actually is ancient. That was actually if you're going to make that argument, you would say that the first industrial revolution was in ancient Rome. So the water wheel, with the geared water wheel, was invented before Rome, but Rome, it exploded as an industrial revolution, literally, in terms of, if you think of EROI, the energy return on investment, substantially increased under the Roman Empire. So they had not just water-powered flour factories, like whole factories, not just like little single stones being turned, but they had massive 32 water wheel multi-stage flour factories that just turn grain into flour 24/7. They had stuff like that, but they also were using water power to run lumber mills. So they were cutting wood and lumber with water power. Stone saws, they had lumber-powered stone saws or water-powered stone saws. There's not direct evidence, but some suggestion that they were grinding sand with water power, and sand was part of the revolution, the glass revolution in the Roman Empire. People underestimate the role of blown glass. It was invented by Syrian craftsmen under the Roman Empire, possibly Jewish, we're not entirely sure. But in the late 1st century BC, early 1st century AD, blown glass was invented. And then it exploded, and it also created a heating revolution, so in heating technology, because now you could have thin, flat-planed glass in large quantities. So you could actually have, for example, Roman baths that were have a lot of natural sunlight that comes in, but the heat stays in because the glass holds it in. So that's actually a massive revolution in heating technology. So you have much more efficient heating stuff. So there's all of this stuff. There's tons of things that go point by point in the factories, multi-component things. So like different components for one product be made in different places, brought together and assembled. There's even the water wheels themselves. We have example in the British Museum of a water wheel kit. And it comes like an IKEA set. You'd get this water wheel, and it'd have all the parts are in there, and they fit in a box. They're neatly fit in the box, and they're all lettered. And then you would get some sort of instruction manual that show you how to put the pieces together according to the letters. So they would manufacture these things and just ship them out. So you just have these basically Roman IKEA version of the water wheel everywhere. So their industry was impressive. There was a lot going on in the Roman industrial technology. The reason we don't normally call it an industrial revolution is because the EROI of fossil fuels is massively greater. I think it's something like 15 to 1. The amount of energy that you spend to get the oil and get it into gas tanks or whatever, or coal, as the case may be in the steam revolution, versus the amount of energy you get out. So you get way more. So the energy scale you get out is huge, and the advantage of that is that it allows us to do massive amounts of things that we couldn't have done before. And so that's what we call it a revolution. It completely transforms civilization. You can't do that with water power. Not mechanical water power anyway. Hydroelectric, you could if there was enough water falling, and there just isn't on Earth. For hydroelectric to power all of our civilization, we have to have fossil fuels or nuclear. Nuclear is much more efficient. By contrast, solar and wind, they have really low EROIs. They're like 2 at best, so 2 to 1 versus 15 to 1. So they don't compete with fossil fuels really in the long run. So you can't run basically, if you were to do the math, if we were to try to turn our whole civilization into solar power, half of our economy would be dedicated to building and installing and maintaining solar panels, which would basically crash our economy, because whereas if for fossil fuels, we're running 1/15 of our economy is spent making and getting the fossil fuels. So we have all the rest, the 85% or the whatever percent of our economy can be devoted to building other things on that small amount of energy that we're pulling out. So fossil fuels, it just changed everything. And so that's why steam power is so radical, and how it gave us the revolution that we see of the 19th century and then into the 20th century. None of that could have happened without steam or fossil fuel in any form. Theoretically, someone could have invented the internal combustion engine before the steam engine, but it's highly unlikely. In fact, they didn't invent the steam engine. It was just luck that they actually ended up developing it. But so that's to correct that in terms of that. The water wheel technology was already ubiquitous and already a fundamental staple of the Roman Empire. When the Roman Empire fell, a lot of that technology just disappeared. It was reinvented and rebuilt in the the late Middle Ages, early Renaissance. So we see water power start to kick up again around 1000 AD, and starts to proliferate. But even that was running for hundreds and hundreds of years until we got the steam engine actually driving an economy. And even that didn't happen until really the 18th century, because, Sayer, the original steam pump was invented in the late 17th century, but we didn't have real effective steam engines until about 50 years later. So it was really, it's the 18th century that it just starts, and it's the 19th century where you see the impact. So that's the Industrial Revolution. What was there was another component to that question? I know I answered part of it, the water power side, but
would the revolution have happened? I mean, how close would it have been? Like we talked about this before in our episode where we talk, did Christians cause the decline? And of course, it wasn't just Christians. We talk.
Yeah, and it's not so much that they caused it as that they didn't fix it. They had no resources to actually solve the problem, basically.
Based on how science was developing, BC into AD, but when it was still up. If we kept an uphill climb. Yeah,
so one way to frame that question is, once again, it relates to something we were talking about over lunch, which people won't know about, but why wasn't there an industrial revolution in ancient Rome?
Right.
Particularly because they had all the components of the steam engine. They knew about steam power. They had steam-powered devices. They had hyper-precise pipe fittings. They had all of the components that were necessary. And by the middle of the 2nd century, they had coal. Because they started mining coal in Britain. And so the question is, why didn't they come up with a steam engine? Or would they have done had they not collapsed, had the society not fallen apart? And the answer is maybe. If you look at what caused the steam engine to be developed when it was, then my answer would be no. And here's why. So in the Roman Empire, most of the science was concentrated in the major cities around the Mediterranean, especially Alexandria. So the one guy we have who's telling us about steam technology, Heron of Alexandria, writing in the 1st century AD, he's in Alexandria. There are no easily accessible coal deposits in Egypt. Britain is way on the other side of the empire, and they're just pulling coal off. They just walk up to a hill and just pulling it off the hill to heat their houses, right? Because there are coal outcroppings just sitting right out there in the open. So these aren't talking to each other. So it isn't. When Heron is talking about steam power, he well knows the amount of wood or even charcoal that you would have to burn to get energy out of that is way more expensive than the food or grain you would feed an oxen or a man to do the same work. Humans and animals are super efficient machines. So it's really hard, especially at that level of technology, it's really hard to even understand how a steam engine would be a practical idea at all. Like it would be like this. Yeah, we can do toy things with it, and we can do fun things with it, but it's not industrially practical at all. It's a waste of money, really. And that still was when Sayer and the original inventors of the steam engine came around, because what happened was, the Romans started mining coal, 2nd century AD, and then you get all the way up to the 17th century AD. So they've been mining coal in England for over 1,000 years, 1,500 plus years. Well, they'd exhausted it all. So they'd mined all the stuff that was outcropping. Now they're digging their actual mines, like they're going in to mine the coal out. And they'd mined all the coal it was easy to get to, and they'd mined all the coal below the water line. So now the only way to get coal was to pump the water out. So you have to pump the water out so you can actually get to the remaining coal, because they've been mining coal for 1,000 years in England. And of course, by that time, people knew that, you could maybe find coal if you go digging in the right places, but you still have to figure out, where do you dig? Where is the coal? And then it's really expensive to dig a mine to get coal. Why would you do that when you already have a working mine in England, et cetera? So it took a while for other coal mines to open up and become a thing. And then, so anyway, in England, they got to pump the water out. And so there's this engineer who's working in the mines there, and he says, well, hey, you know what? Here's the thing. We're mining coal. If we burn some of that coal, use steam to pump the water out, it doesn't cost us anything. It's a net profit. We're actually making more coal than we're burning, right? So it was actually the one scenario in which it was actually cost efficient to use this crappy little steam pump that he invented. which no one else would ever use because a human operating it would be cheaper normally. But in this particular case, it's cheaper to run it with coal because you're getting free coal out of it. It's a net profit in coal. So he does this. So he develops this machine. Now the machine exists, right? And it works. Now people are noticing this and like, okay, well, what if we make this machine more efficient, we waste less coal, so we're making even more coal, right? And so they're thinking about, let's make it more efficient, let's make it more efficient. And that's over the next 50 years, you get increasing efficiency in steam engine until they cross that threshold to the steam engine power is more efficient than animal or human power, more efficient than water power. So it's getting super efficient, not by modern standards, but by that standard. It got to the point where it was actually cheaper to steam a ship with coal than to have rowers, for example. And so same with factories. To run a machine with coal was cheaper than to have humans running in a hamster wheel or having horses turn a turnstile or whatever. So that just drove everything. So once you got to that point, well, then it's just increasing efficiency. You get more and more advanced steam engines, and then eventually you get the internal combustion engine, and people are using oil instead of coal, and it goes on. And then now we're doing electric, and so it's that set that whole ramp up for us to exploit energy out of nature that we couldn't before. But it all started from Sayer figuring that one thing out, is like we could make more coal, and it would cost us nothing net if we use a steam-powered pump. And so that's one cheap, crappy little steam-powered pump that was not efficient at all, started the whole process. And so you think, like, what would it have taken for the Romans to do the same thing? Well, it would have taken them 1,000 years to mine all the coal out for the right, for them to be in this conundrum in order to have to solve it. And it was only by solving that conundrum that they realized that you could actually increase the efficiency of the device. And it took like decades of increasing that efficiency to finally realize that, oh, we can increase efficiency so much that this is actually way better than anything else we have, right? So that's why I think we probably would not have seen an industrial revolution in ancient Rome. The scientific revolution, however, is a completely different story.
Yeah, it is. That's right.
Wow. Thank you.
Yeah.